all the basic rules of all of math courses, all of the math courses. First ones you're going to start off with are the properties of math. By properties, I'm talking about what do we do when we're given an equation. This precedes the order of operations. The first property that we're going to talk about commutative property of. What's to commute mean? Same spots. Yeah, this one tells us about moving. Property of. That means there are two of them. Commutative property of addition. Again, this is being recorded. I'm going to send you all this stuff anyway. So if you want to write, you can take notes. If not, I'm going to send it to you. The commutative property of addition says this. Plus y, that equals the same thing as y plus x. Three plus 4 is the same thing as 4 plus 3. They both equal 7. So that's what so in other words, it doesn't matter how it's arranged. I can move them around if I need to. The second of those is the commutative property multiplication. The commutative property of multiplication says x times y is the same thing as y times x. Three times 4 is the same thing as 4 times 3. What is 4 times 3? 3 times 4. 12 equals 12. So it doesn't matter how it's arranged. That's the commutative property. It says this, what this rule says is we have the ability to move our numbers around if we need to. The second property is the associative property, or T, of the associative property of. Associate with things. What we're doing here is this one deals with grouping. The associative property deals with grouping. Again, we have two of them. The associative property of addition says this. Plus y plus z equals x plus y plus z. True? X plus y plus z equals x plus y plus z. That's true. But here's the problem. Our known universe can process more than 2 bits of information at any one time. So if I give you 3 numbers, if I give you numbers like 3 plus 4 plus 5, what would you do first? Move left, right. But then that doesn't help us any. What if I want to do these two first? This is where the concept of parentheses comes in. The parentheses isolate what we have to do first. But you're right. Otherwise, if they weren't there, you would go left to right. But since there's parentheses there, since there are parentheses, we have to do the parentheses first. 3 plus 4 is 7. How about the other side? 4 plus 5 is 9. 7 plus 5 is 12. 3 plus 9 is 12. So now what does this rule tell us? If we have a series of numbers, then we can choose whatever pair we want to do first. If the operations are all the same, we can choose which ones we can combine. It'll become more apparent in this next example. Associative property multiplication. This x times y times z is equal to x times y times z. Same numbers. 3 times 4 times 5. 3 times 4 times 5. Work this and tell me which side you think is easier. Work it out first. You have to see it. You have to do it to see it to understand. On the left side, what do you have to do first? 3 times 4 is 12 times 5. What is 12 times 5? We have 4 times 5 is 3 times 3. What side's easier to do? The right side, because here, whenever a number ends in a 0, you do 3 times 2 is 6 and put a 0 behind it. In this one, what do you have to do first? 5 times 2 is a 10. Put the 0, carry the 1. So there's a lot more moving. The more moving you do, the more chance of mistake you have. So that's the beauty of this, is if I have a series of numbers, I could combine them however I need to, whatever's easiest for me. I would definitely do the right-hand side. So far, so good? Those are the first two properties. The third property distributive property. The distributive property is probably the most important property we have. This one does two things. This one doesn't have of at the end of it. There's not a list after it, addition multiplication, because it puts them both together. Here's the distributive property. A times x plus y. Whenever you have a parenthesis or a letter, whatever's in front of it, what is it called? It's got a name. What is the thing in front of a parenthesis called? Starts with a C. What's that? It could be another letter. Letters are variables. This is called a it's called a coefficient. The coefficient is the number in front. Coefficient tell me to do? It tells me to multiply where? To every element inside there. So what do I get? A times x is ax. Is it plus? It's a times y is ay. Why is it plus? There's a plus sign. Yes. So Whenever you do multiplication like this, treat the signs and the numbers differently. Well, it causes most mistakes in any math problems, in any grade level. Yep, that sign. It could be a negative, it could be a minus. It disappears, it comes in every now and then. That's the killer of most grades. So, whenever you do that, you remember the rule is if the signs are the same and you're multiplying them. Positive times positive is a positive. Negative times a negative is what? Positive. Positive times negative, and negative times positive. So if the signs are the same, it becomes a positive. If the signs are different, it becomes a negative. Same thing we're doing here. Is A positive or negative? There's no sign. So positive times positive is positive. So it's A times X. Positive times positive, that's why that's positive. Then A times Y. It sounds ridiculous, but once you get used to doing signs and numbers differently, you will never have that problem again. This is the most powerful property we have because it does two things. Chemistry class. In chemistry, you have a balancing of equations. It's called stoichiometry. If I go from the left side to the right side, I get that, right? That's called distributivity. If I go from the right to the left, that's called what do they both have in common? They both have an A. So if they both have an A, we take out the A, what do we have left? X plus 1, right. So that's what I'm saying. That's why this property is important, because we can separate equations and we can combine equations. That's why this one's pretty powerful. This example. This is a coefficient, so we multiply everything inside the parentheses. Negative times positive is what? Negative, so the answer is negative. 3 times 2 is X. Negative times negative. 3 times 5. That's what I'm saying, but if you do that, your number of mistakes will drop tremendously. Unity property of addition what this thing says is what plus X gives me X. Remember, what if it was 3? 3 plus what equals 3? 0. So whenever you add 0 to a number, it doesn't change it. How about if I multiply it? But this one is what? Times something equals X. Yeah. That's the unitary property. So 3 times 1 is equal to 3. The nullity, oops. The nullity property of this one says, what do I need to get to remove it? Plus what gives me 0? Listen, 3 plus what gives me 0? -3. So it's what this is also, look at the inverses of it. So whatever number I have, if I add the opposite sign to it, of that same number, it becomes 0. So -5 plus what gives me 0? +5. So if the numbers are the same and the signs are different, and I add them, they disappear. I'll also call the inverse. Look at these as the inverse properties. So in multiplication, x times what equals 1. So 3 times what equals 1. Inverse. Flip it. So if I had 1/3, the 3's cancel, so I just get 1. The x's cancel. Remember, every number is a fraction. So this is 3/1. If I multiply by the flip of it, the 3's cancel and the 1's cancel, leaving me with 1. So if I'm multiplying and I want to get rid of something, I have to multiply by the flip of it. The inverse of 2/5. If I multiply by 5/2, I get 1. Because the 2's cancel and the 5's cancel. On these, so don't worry about it. If you get this, I'm going to keep on repeating these rules all throughout the semester. So don't sweat if it doesn't stick right now. It'll stick eventually. So yeah, and you've seen this stuff before, but these are the ones. These are the basic rules that cause the most troubles. Because if you have trouble with these, everything else is gone. The second thing I want to talk about the order of operations. We use the word PEMDAS. Keep away from that. How many of y'all use PEMDAS when you do things? What's this answer going to be? It's 9? Anybody else have another answer? There's another answer you can get. What order of operations? Inside the parenthesis, what is 5 minus 2? Okay. PEMDAS does you multiplication before division. 2 times 3 is 6. Isn't 6 divided by 6, isn't that 1? 6 divided by 6 is 1. Anything divided by itself is 1. So that's what I'm saying. With PEMDAS, it's too much things to worry about. Order of operations simply has one set of rules. Read left to right. 6 divided by 2 is 3. 3 times 3 is 9. The other half class will get 1. So the first off, in order of operations, the first thing you always do are special operations. In PEMDAS is in mathematics there are over 400 symbols, not parentheses and exponents. What about those? What about these? In calculus, we have integrals. We have, in statistics, we have factorials. PEMDAS never uses any of these. So that's why keep away from PEMDAS. That was introduced in elementary school, it should stay there. These are all the rules now we're going to get mathematics. As you go through math, you'll have more and more and more symbols that you can live with. So, first thing, do anything special. Also, what about brackets? PEMDAS doesn't talk about brackets. So do any special operations first, whatever's inside there. Multiplication and division. They're on the same level of importance. Multiplication is no more important than division. And then addition and subtraction. That's all you have to memorize. Anything weird looking, do that first. Then multiplication, division, and then addition, subtraction. This is a language. When you put a math equation up there, it's actually called a statement. A statement is what we talk about here. Anything I'm saying is a statement. How would you read that? Yeah. 3 plus just the way you read it. So if I gave you this, we can go from the English statement to the math statement. You read left to right. The operations, on the other hand, we do using order of operations. So when you read a math statement, you read left to right. The same way you do reading in English, any textbook. Read left to right. Which is interesting because algebra was invented in Saudi Arabia, in the Middle East, and they read right to left, which is amazing, interesting. Work that one out. It doesn't matter how big or how small it is, it always follows the same rules. Y'all see it in the back? You need to write it down. So these are the three answers we have so far. So when you do this, read left to right. Read left to right. Are there any special operations? No. Here's a bracket, a parenthesis. So we have to do inside the parenthesis first. So inside the parenthesis, we repeat the process. Are there any special operations? Yes. Here's a parenthesis right here. That's not true. Here's a special right here. So we have to do this first. Plus 2 is that's my first step. Repeat the process. Read left to right. Any special operations? Here's a parenthesis. It opens here, it closes here. So I have to do inside here. So left to right. Are there any special operations? Yeah, can I do anything inside that? No. So inside here, are there any multiplication divisions? So we have 2 plus 3. Positive times negative is negative. 5 times 6 is 30. Minus 3 plus 2. Get the process, left to right. Special operations, right here. Inside there, any special operations? No. Multiplication, division? No. So all we have is addition, subtraction. Read left to right. 6 minus 30. Talk about that in a second. Negative 24. Repeat the process. Left to right. Special operations. So to do inside here. They're both negative. 24 plus 3 is 27. Left to right. I can't do anything inside here. Since I can't do anything inside there, I have to get rid of the parentheses. So I multiply. Positive times negative is negative. 3 times 27. 7 times 3 is 21. Three times 2 is 6, plus 2 is 8, so it's 81. Left to right, no special operations, no multiplication division, so positive 2 minus 81. 79. I'll show you the rules of this one in a second, of why that is. No special operations, no multiplication division, so the answer is going to be negative 77. Trust me, more learning will happen when you mess up than if you just got it right. In here, I had a couple of rules about addition and subtractions of signed numbers. Let's think about those. Let's talk about those real quick. Rules for adding, subtracting. Oops, I'm sorry. Add. It becomes a problem when we have different signed numbers. Addition is this. if the signs are the same, take the common sign and add the numbers. If the signs are the same, take the common sign, the sign they're both on, and add the numbers. They're both positive, so the answer is going to be positive. 3 plus 5 is 8. -7 minus 9. They're both negative, so the answer is negative. 9 plus 7 is 16. So if the signs are the same, keep the sign and add the numbers. And subtraction. If the signs are different, take the sign of the larger number and subtract the two numbers. So if the signs are different, take the sign of the bigger number and subtract the numbers. When I say subtract, I always mean larger minus smaller, right? It's always going to work. 9 minus 6. Is the answer going to be positive or negative? Why? Because 9 is bigger than 6 and it's positive. So the answer will be positive. 9 minus 6 is 3. -6 plus 8. Is the answer going to be positive or negative? Positive. 8 is bigger than 6. The answer is positive. 8 minus 6 is 2. 3 minus 9. 9 is bigger than 3. It's negative, so the answer is negative. 9 minus 3 is 6. Negative 12 plus 12 is bigger than 6. It's negative. 12 minus 6 is 6. Or where most mistakes occur. Again, it's because of the negative sign. Not because the numbers are hard or the operation's hard. It's because the negative sign really ruins your day. Let's try another one of those big ones. Make up another one. Finished? If I'm going too fast, if I flip the page, tell me to put it back. I don't mind. I'll go back and put the page back. Yeah, it's got it. What do we do first? Left or right? Here's a special operation, so we do inside this. This is where it starts, this is where it stops. Inside here, left to right, here's a special operation. There. Cards to an eye doctor. -4 plus 1 is what?
-3.
Yeah, since 4 is bigger, the answer is negative. 4 minus 1 is -3. Repeat the process. Left to right. Here's special operation. Inside here, can I do anything with this parenthesis? No, because I can't do anything with it, I have to get rid of it. How do you get rid of parentheses? Using which property? Distributive property. The distributive property whole purpose is to get rid of parentheses. So, here we have a positive times negative, 2 times 3, 6. Everything else. Read left, right again. Here's a parenthesis. We have -2 plus 3.
Okay.
I wonder why it's bad focusing. Oh, that's not good. I don't like that. Inside here, what do we do? Are there any special operations? No. Multiplication, division? No. So we have addition, subtraction. 5 minus 6.
-1.
6 is bigger than 5. It's negative. 6 minus 5 is 1. Repeat the process. Here's a special operation. -1 minus 3.
-4.
They're both negative, so I take the sign and add the numbers. 1 plus 3 is 4. So good?
Yeah.
Left to right. Here's a parenthesis. We can't do anything with this parenthesis, so we have to get rid of it. Multiply. Negative times negative is a
Positive.
4 times 4,
16.
16. Left to right, here's a parenthesis. Minus 3. 3 is bigger than 2. It's negative, so its answer is negative. 3 minus 2 is 1. Left to right. I can't do anything inside of the parentheses, so I have to get rid of the parentheses. By distributivity. So we have positive times negative is negative. 5 times 1 is 5. All the parentheses are gone. No more multiplication divisions. So left to right. -2 plus 3.
1.
It's a positive. 3 minus 2 is 1. Left to right. They're both positive.
17.
1 plus 16 is 17. 17 is bigger than 5, so it's positive. 17 minus 5 is 12. You see where the steps are. It's always the same process. Now, is this a lot of writing? Yes, because you have to make sure you understand the rules. I tell my students this. It's cheaper to buy paper than to repeat this course. A ream of paper only costs $1 or $2. This course costs a couple $100. So take all the paper you need. So far, so good?
Can you bring
Where were the most common mistakes? Those of you who had these answers, where were the most common mistakes?
I made my mistake on my
This one.
year.
What part? You do. You have to do inside the parenthesis first. Start distributing?
Yeah.
Okay, I'm glad you said that because ideally it shouldn't matter. Let's see, if we had this. So here's an example. They should give us the same answer. In this way, let's use the order of operations. And this way, we'll use distributivity. So we'll do inside the parenthesis first. Negative and negative, they're both negative. 3 plus 1 is 4. Negative times negative is positive. 4 times 4 is 16. So the answer should be 16. Let's distribute. So negative times negative is a positive. 4 times 1 is 4. Negative times negative is a positive. 4 times 3 is 12. 4 plus 12 is 16. So it should give us the same answer. But that's the reason I threw a lot of those negatives in there, simply to throw you. And this is right now for this. In a minute, we're going to do multiplication divisions problems. Negatives. I'll show you short. It's the same rules though, same shortcuts. So that's addition, subtraction, and multiplication. Okay, before I go into this, we have two types of statements in mathematics. We have what are called expressions. And then we have equations. The symbol equals is part of an equation. This one has an equal sign. This one does not have an equal sign. There's a difference. If there's no sign, all you do is simplify. If there's an equal, we solve. So if there's an equal sign, we're not done until there's one answer. In expressions, if there's no equal sign, we just combine like terms. For example, what is that? They both have x's. So we have 3x's plus 5x's, they're 8x's. Math without having a rule says we can do it. So what rule says we can do what we just did? That's not a rule, that's just a operation, a process. The distributive, the distributive property. What do these two have in common?
The X.
They both have an x. If I take out the x's, what do I have left?
3 plus 5.
What's 3 plus 5?
8.
8x. That's where it came from. It's just that when we combine like terms, we skip this middle step. When we combine like terms, we'll come back to this in a minute. Combine like terms. What does the word term mean? What is a term? We use a statement in a sentence. No, a term is anything separated by a plus or minus. Actually, or later when we get to or equals. Those are terms. A term is anything separated by a plus or minus. We're looking at it for right now. So 3x plus 5x has how many terms? Two terms. Here's a term, here's a term. Combine like terms. Are they like terms? Yeah. What you look for are the variables. If they're both x's, then they're like terms. All I have to do now is combine the coefficients. You see how math is its own language? All these words, coefficient, combine, variables, all of this stuff defines what we have to do. How about if we had this? You do what?
15x.
But how many x's do we have? (15x squared). Have you ever seen that thingy there? What's that called? It's called the exponent. What does an exponent represent? The number of times the base, which is this number, is multiplied to itself. So the exponent tells me how many times is it multiplied to itself. So if I had x times x times x times x, I can rewrite that how?
X to the fourth.
Right. So x times x becomes x squared. When you add and subtract them, because of the distributive property, we don't change the powers. When you add and subtract terms, you only change the coefficient. When you add or subtract like terms, only change the coefficient. When you multiply and divide them, multiply or divide terms, you change everything. Change the coefficient, and exponents of the variable. Can I read that? I got really sloppy there, I'm sorry. Or divide like terms. You change the coefficients and the exponents of the variables. What do I mean by variable? The letter. Because 3x times 5x, the variable is x. So Whenever you hear the word variable, that represents just the letter being used. When you multiply them, I could change the coefficients. 3 times 5 is 15. X times X. I now added two of them together. Later on, we'll get to the rules of why that's x squared and all these other exponents. But there's a reason, there has to be a mathematical reason why, where it came from. And that's what we'll get to later on. What happens here? 3x. There. How about this one? Simplifying, yes. We're not, when would we solve it? If we had equal sign. Very good. Good catch, good catch. You did. Work it out.
Oh, okay.
Oh, you're writing it? Okay. Actually, I'm going to send you all copies of those. I'm going to scan them and send them to you. What's that? I'm going to send you all copies of those. So that'll save you having to write everything. Got the answer right.
Oh, right.
So what method do we use here? Distributive property. Positive times positive is positive. 3 times 2? X times X? Positive times positive? 3 times 5? X times Y. That's it. We change exponents if it's the same base. X times X is X squared. X times Y is XY. I'm not going to lie to you. Mathematics is nothing but rules. And that's what we're going to go through. And every time we do a problem, I'm going to go back and review the rules. So even in week 14, I was like, okay, go step by step by step by step. That's the beauty of this stuff. So far, so good? You getting better? So everybody's okay with adding and subtracting numbers and multiplying numbers. How about adding fractions? Yeah. Yeah, the butterfly method. Use the butterfly method. 3 over 4 plus 2 over 5. Okay, let's start with the same base then. That was ugly. 3 over 4 plus 1 over 4. Introduced this to a bunch of seniors a couple of semesters back, and they fell in love with it. You all probably know about it. It's the butterfly method. When you add or subtract fractions, draw a butterfly. On this, multiply these. 3 times 4 is 12. Whatever operation there is, that's a plus. 4 times 1 is 4. So these numbers go on top. We have 12 plus 4. On the bottom, multiply. 4 times 4 is 12 plus 4 is 16. 16 over 16 is 1. It also works if it's not the same bases. What number goes here? 5 times 3 is 15. There's a plus. Times 2. So on the top here, it's 15 plus 8. And on the bottom, multiply these two. 15 plus 8 is 23 over 20. Makes it easier, doesn't it? Same thing works for a subtraction. No, we'll get that in a second. Yeah, we'll get back to that one. Simplify. Yeah, we'll get that.
You never want to think
Right. What would this one be? What I could do is, if I have a minus sign in the middle, this minus sign to that top of that second one. I'm giving an example where they're both going to be negative, so that makes a little problem. What goes here? 4 times 2 is 8. There's a plus sign. Positive times negative is negative. 3 times 1 is 3. So on the top, I have 8 plus negative 3. Bottom, I got what? 3 times 4 is 12. So here I have opposite signs. Positive and negative becomes a negative. So it's 8 minus 3 is I can see in your face that you wish you would have known that 20 years ago. I have people same thing. Is say if my teachers only would show that, even if it sounds Mickey Mouse, I still do it. Let's make them both negative, both fractions negative. Negative 2 over 7 minus 1 over 3. Work that one out. Right. Again, what I like to do is take this negative and move it up there, so it's a plus negative 1/3. My butterfly. So negative times positive is negative. 2 times 3 is 6. Negative times positive is negative. 1 times 7 is 7. So it's negative 6 plus negative 7. 7 times 3 is 21. So you can't have two signs, so positive times negative is a negative. So -6, -7. Yeah, remember what we said, since the signs are the same, we keep the common sign and do what with the numbers? Add the numbers. 7 plus 6 is, should make it much easier. The two types of fractions we have, proper versus improper. Proper fractions. We always want, the common convention in mathematics is you only want proper fractions. If you have an improper fraction, you have to convert them to what are called mixed numbers. Where they have an integer and a fraction. Let's look at this. Times does 2 go into 5? How many left over? Over 2. There's your mixed number. This one. 4 goes into 9 twice, with 1 left over, and this is always the bottom number. Yeah, whatever's down here will always be the bottom of the fraction. Remind me next week to give you all, I have small multiplication cards. We're making, 5 goes into 27 5 times. 2 left over. So, let's go from mixed number to improper fraction. Something like that. When would we go from a mixed number to an improper fraction? You want to add and subtract fractions. Or divide, right. It makes it much easier that way. So here we have the mixed number. The way you do it is take the coefficient, the number in front, multiply the base, the denominator. Add the top number over the bottom. That's how you do it. Here's an example we just did a second ago. So if I give you 2 1/2, 2 times 2 is 4, plus 1 is 5, over 2. This one's always the denominator, which is what we start off with. Whenever we do add subtracting. What do y'all think? A lot of stuff so far? I mean, we can keep on going. we could do a little bit more of this stuff, or we can call it a day. So I don't want to overdo your heads.
You want to go?
I open the door, right? Let's do one more thing, because you still have, online, you have your homework assignments.
Oh.
And let's look at square roots. What are square roots? They're also called radicals, and it looks like this. That's a square root. But it does. A square root needs two of a kind to take it out of the inside. Called a square root. Nope. And the number has to be multiplied by itself, right? Yes. For example, then, we all know that the square root of 4 is 2. But what is 4 made up of? 4 is made up of 2 times 2. Once you have a pair of numbers, you can take it out of the radical. So since you have two 2's, and since there's nothing left inside there, that disappears. Square root of 16. 16 is made up of 4 times 4. We have a pair of 4's, so they come out in front. There's nothing left inside there, so it disappears. So far, so good? I mean, that's what you're looking for. You're looking for a pair of numbers that are the same. Square root of 8. To find the square root of a number, here's, well, not the exponent. First thing you have to do is to factor the number that's inside there. So, what is 8 made up of? 2 times 4. What is 4 made up of?
2 times 2.
Can't go any further. They're called prime numbers. So, 8 is 2 times 2 times 2. There's 3 2's, right? What kind do we need? Once we have two of a kind, that comes out in front. So these are gone. What do I have left? The 2 inside there. That's the answer. You have to first factor out the number to its prime factors. And then look for pairs of numbers. How about square root of 12? Again, take the number here. What is 12 made up of? 2 times, what is, 2 can't go any further. What is 6 made up of? So it's made up of 2 times 2. Right. So here we have a pair of numbers. It comes out. All we have left. Pretty cool. Like let's say square root of 36. Let's take a square root of 36. We know square root of 36 is what? We don't know. Good. Let's see. So 36 is made up of what? Six times 6. 6 is made up of? 3 times 2. Yeah, by cumulativity, it doesn't matter. So here we have 2 times 2 times 3 times 3. A pair of 2's, and I have a pair of 3's. So it doesn't matter how big or how small the numbers. So again, now I can give you, let's figure this one out. Doesn't matter how big the number is. Let's solve this one. Let's look at this number. This number 146. It ends in an even number. If it ends in an even number, we know it's divisible by 2. If it ends in an even number, it's divisible by 2. So how many times 2 go into 14? 2 goes into 6? 3. Can 73 be broken down into anything?
No.
It's a prime number. So this is as far as it goes. It's simplified. Nope. This one's square root of 52. So you see, the hardest part so far in this course is remembering your multiplication table. So what is 52 made up of? Well, it ends in a 2, so we know what? 2 goes into 5 how many times? With how many left over? 2 goes into 12, 6. 26 can break down. What is 26 made up of? It ends in a 2. 2 goes into 2 once. 2 goes into 6 3 times. Pair of 2's. Make sense? So first thing you would do, whatever's inside the radical, break it down as far as you can go and look for pairs of numbers. Once you find a pair of numbers, take it out of the radical and whatever you have left, whatever's at the very end, multiply them again and you're done. So good? Any questions? That we'll do that next time. All we're doing is simplifying. We haven't started solving equations. We're just simplifying. We're working our way to solving equations. All we're doing is combining like terms and simplifying them. There's no equal signs in anything we've done so far. We're only simplifying. The solving one, that's what the meat of the subject is going to be. We'll do that next week. So let's stop there today. You should be able to finish 1.8 today on my math lab. Let me see. Section 1.8 deals with exponents, square roots, and order of operations. You should be able to do that on your homework. Let me see. Student view. So your homework for section 1.8 is just that. It's the one we just looked at. It's the exponents, it's, right. I mean, if you want to go ahead and do chapter 2, go ahead. See what?
What is it?
I just showed you. This is 1.8, is exponents, roots.
Fractions.
Yeah, chapter 2 is fractions, and that's why I want to stop it there.
Yes, they were on it.
No, I guarantee you, once you see these patterns here, it's super easy. But yeah, all you have to worry about right now is section 1.8. 12. We have. In this class, we have 2 classes, remember, we have the
Yeah.
BASM. In this one, we have chapters 1, 2, 3, 8, a little bit of 8 and a little bit of 9. One section in 8 and 9.
Okay.
Once we finish that, then we'll do the other half of the course. Yeah, I believe it. So it's not that much work. I mean, we'll have a lot of free time in the class to, for this half of the class, yeah. Everybody, that's it for today.